Thank you so much for joining us today for Transforming Construction with GIS. I'm Maria, and I have today with me, I have Vince Novak and Nick DiPaolo, and we're going to go through some use cases and some exciting things we're working on here at JMT.
Thanks, Maria. Nick DiPaolo here with JMT. I have a background in GIS, but my new role now is service line leader of digital transformation. And digital transformation is a term that you hear a lot of different folks talk about nowadays. At JMT, we define it as evaluating and investigating how innovative technology can be applied throughout the infrastructure lifecycle to add value and support downstream project needs. So we're exploring different opportunities, and we're going to showcase some of them today with you here related to digital transformation. I'm going to introduce my colleague, Vince Novak, who will introduce himself as well.
Hi, everyone. Vince Novak. I'm the service line lead for digital experience. Nick and I are collaborating as well as we're collaborating with every group within JMT to really see how we can apply some of these new innovative technologies to our project workflows. So my team and I are really focused on the end user experience for how we can utilize all these different technologies. We look a lot at things like augmented reality and virtual reality. We'll talk about exactly what those are, but trying to figure out ways that we can apply those things throughout our workflow. We have our virtual spaces product that we utilize to do a lot of different visualizations and work in collaborating and communicating with our end users and our stakeholders. So all that is really part of what we're focused on when we talk about digital experience here at JMT. So just to give you a little bit of a context, as we're moving towards this idea, this concept of digital delivery, where our plans are not just two-dimensional, they're three-dimensional models that are created as part of the design process, and then they live on throughout the entire project process and even after delivery as complete 3D models, right? So the delivery methodologies there are preserved, but it opens up a lot of opportunities for us to apply new innovations for the ways that we can communicate and collaborate with all of our different stakeholders. So immersive technology is one fantastic way that we can really add a lot of value when we have a 3D model that we have available to us. So using things that will immerse you in a full digital environment, whether it's on your desktop or using some type of augmented reality or virtual reality, even things like 360 photos and real-time models and visualizations are all kind of contained in this idea of immersive technology that we can use to really help others visualize and understand our designs and the processes that we're going through. Augmented reality, or AR/VR, is a term that we're going to use a lot throughout our presentation. Augmented reality is any kind of technology that you would utilize that would allow you to see the real world around you, but it adds an additional layer of information, gives you some additional insights into the world that you're looking at. With something like virtual reality, you're completely immersed. You're taken to some place where you're not, and you're allowed to kind of interact with that environment and really kind of understand it, even though you're not on site or on this particular location. And one of the biggest advantages that we have with a model-based framework and having 3D models available to us is the ability to create innovative project controls and digital twins at the end of a project. So those things need to be validated. Everything that's being built needs to have additional levels of accuracy. They go into asset management and maintenance cycles, and having that 3D information, that 3D data, allows us to create a digital twin that lives on throughout the whole project and after the project is completed, so that we can do better analysis, we can have better visualizations, we can do a lot of different simulations and things like that, using a digital twin of that real world structure, that real world thing that's created. So these tools really can be used throughout the entire project lifecycle. In the planning phase, we can look at different design alternatives. We can collaborate with our stakeholders and make really informed decisions about exactly what's going to be built and the different options that we have available to us. When we're talking about public outreach and stakeholder engagement, allowing users and stakeholders to look at more than just a 2D plan gives us a lot more value and a lot better collaboration to make decisions and help people really understand what's going to be built in their environment, how it's going to affect their community, and ultimately get their buy-in so that we make sure that we don't have things like project delays or any type of issues with any kind of constructability. On the design and construction phase, we can use these tools to help really innovate with our workflows, make our workflows a lot more efficient, make sure that we can validate what's being built and really address issues in real time and make those issues much more manageable, whenever project issues potentially come up. And at the end, like we mentioned before, when we go into asset management and a project has been delivered and has to go into a maintenance cycle, there's a lot of efficiencies that can be built. There's a lot of safety that can be gleaned from having these AR/VR tools, where people don't have to necessarily be on site. We don't have to necessarily put people in dangerous areas or situations. And it also allows us to do more real-time communication and collaboration as we're doing those inspections and things like that. So we want to break it down into each one of these different verticals, and I'm going to hand it over to Nick here to show some examples of ways that we can use these technologies in the early stages, planning phases of projects.
Thanks. Okay, we can stop the video for a second. So throughout the presentation, Vince and I will highlight AR/VR use cases throughout the project lifecycle, as he said. In the examples, we're going to lead with the problem, discuss the technology chosen and the results, including lessons learned. For many of the use cases, especially in the field, we will demonstrate how field staff can utilize tools they already have in their pockets, which really allows for nimble workflows. I want to preface that not every workflow and use case can be achieved solely with out-of-the-box tools. Yeah, there's some great ones out there like ArcGIS, AutoCAD, Unity, vSite, and others, but it takes an experienced team to connect the dots and put it all together. When it's done successfully, the end result provides situational awareness and seamless collaboration between the field and the office, ultimately leading to better data-driven decision-making. This first example demonstrates the need to understand the current conditions of a project site. This is a park in Philadelphia where JMT is contracted to support restoration of the stream and highlight soil erosion and flooding in the park. It's difficult to use a drone in this place to get situational awareness, this park, because of the tree coverage, and it's not an area that's very conducive to bringing expensive terrestrial LiDAR into the park because of the steep terrain and whatnot. But what if we could use different tools like a 360 camera and the ArcGIS oriented imagery layer to create a virtual tour, to bring that situational awareness to the designers and those that are planning the design for the improvements. So what's great is we brought a 360 camera out there. We're able to capture this information with the field staff, paired with the GPS, and create an upload into that oriented image layer in Esri, and then load that into an experience builder page where it's web-based and the user can go through and they can exactly see, just like with Google Street View, you can see exactly where you're at and kind of navigate there throughout the project site, also bringing in additional GIS and CAD layers as needed for analysis. And what's great is you can go back through the project at different stages to document progress throughout it. So, okay, what if we want to look at this same project from a slightly different scenario? It's great to have the 360 imagery because it can really show real field conditions. But what if I wanted to grab that same content and pull it into an environment where I can interact with it more? Here we took a high resolution digital camera, in this case a GoPro Hero 13, and took multiple pictures of a specific area of the project where there's significant soil erosion. And using tools like ArcGIS Reality or Bentley's iTwins, you can stitch these together to photogrammetry and create a 3D mesh. That 3D mesh can then be brought into, because of the spatial coordinates, into an AutoCAD or a GIS or a Bentley product and can be used for planning purposes. You can take measurements and volume calculations off of that mesh that you would not be able to do with a 360 camera or just a regular digital picture. So it's the idea of really, they're going to take pictures while they're out in the field anyway, but knowing what the end goal and the uses are available really kind of dictates the workflow and being able to offer this product that is much more interactive and usable than just a regular digital picture. Okay, I'm going to switch gears now to a slightly different use case. A lot of our clients are utilities, utility companies that have to manage right-of-ways. And it feels like a constant battle to locate and manage those right-of-ways, especially managing encroachments. The right-of-ways are surveyed by licensed surveyors to ensure accurate mapping. Pictured here is a Duke Power right-of-way in South Carolina. Our survey team was asked to confirm that there's an encroachment going on, meaning someone has built into that right-of-way with some of their house or whatever. As you can see here, the encroachment is well documented. The green lines represent the right-of-way, and the purple represent the parcel polygons. It shows the encroachment, but does it tell the whole story? And that's kind of where we feel that augmented reality can really come in and add some value to the project. This aerial is actually about 2 or 3 years old, but it's the most current available for this area. It's somewhat rural portion of South Carolina. I want you to pay special attention to the building with the red roof, and then slightly to the right of that, how that's all open right now, because it's not exactly the way it is today. This is the same view from the ground as seen through the augmented reality application on an iPad. It's paired with a GPS to provide higher spatial accuracy. Again, the green lines represent the actual right-of-way. And the iPad is simply pointed at the right-of-way, and then the survey data is projected onto the screen as the user walks the site. The encroachment is clearly visible, seen going through that shed. But as you walk beyond the tower lattice, you'll see that on the backside, the encroachment also shows that there's a garden that's been built. Pairing the right-of-way data with the augmented reality captures the real-time field conditions necessary to properly document the right-of-way in a way that a normal digital picture of the site cannot, because the right-of-way cannot be displayed on that picture. Note that this is not meant to replace survey teams mapping right-of-ways. We need their level of accuracy and precision to document the right-of-way locations. Rather, survey teams can't always be in the field every day with our field staff. And these AR tools extend the ability to view that data when those survey crews aren't there. The augmented reality allows the field to more accurately document the encroachments than traditional methods, which could be useful when addressing these encroachments with the community, neighbors, or with the utility company themselves.
One of the other ways that we can use AR/VR technologies is actually helping people understand something before it's actually built. So talking about full-size models that we can view at scale in tools like the Apple Vision Pro or the Meta Quest goggles. So you can see here we've got a full model that's either horizontal or vertical in a BIM format. And we can use things like the Apple Vision Pro to go on site and kind of see those actual models at full scale in augmented reality. Here you can see you're walking through that entire site to try and get an idea of how that building would be oriented on that new site plan. You can walk in and exterior of the buildings. And if we have all that 3D model data, we can actually turn on and off different elements and kind of inspect and look at different parameters, different details of that particular model, so that we can kind of get really good awareness of exactly how that model would potentially align in that new space. We're going to shift gears a little bit and we'll talk about public and stakeholder engagement and how we can use these tools to really communicate with our end users. So like I mentioned before, so many of our projects have some level of public and stakeholder engagement that are critical to project delivery and being able to do the planning and make design decisions and really move any kind of project forward, right? So it really just helps let people understand and visualize in a way that is really difficult when you're just looking at a poster of a 2D map or an overhead satellite view. So just a couple examples of how we're using the immersive technologies, for those use cases. In here, we had a project where we had a 3D model of a bridge, and we wanted to be able to show folks what exactly that model is going to look like, what that new structure was going to look like inside their actual communities. So here you can have a web-based view that users can access. They can come in, they can enter in their exact address and kind of get a view of exactly what this is going to look like right from their property, looking northeast, southwest. We can even adjust how far off the ground they're looking to give them a really good immersive perspective on exactly what this is going to do and how these things are going to change. And you can kind of see things like property lines or right-of-way lines are draped over that 3D geospatial information. So as we bring all these things together, we can really give users an up-close view of exactly what's going to happen in their communities, how those things are going to affect, where the right-of-way lies, where the property lies, and things like that to help just that overall communication. Another way that we can use them are in public spaces. So Nick is going to talk a little bit about virtual positioning systems later on, but this is an example of how we're using that type of technology and allowing users to experience a potential structure in an actual environment before it's built. So in this case, users can bring the technology that they already have, whether it's an iPad or a mobile phone, and come out into an environment and scan a structure as kind of a reference point, and use that to see the 3D model of the entire space. So here we used a public structure. There's a statue that we can reference, and then we can project that 3D model inside of that entire park space, so people can kind of understand exactly where that model is going to be placed. They can see how it might change that particular environment. Our construction teams could even potentially use this as a way to validate things that are being built in real time and kind of compare that geo-referenced model to the actual as-built conditions for better collaboration as the project proceeds. So we'll switch gears again. We'll go over into our design and construction phase. We've already made a lot of decisions. The planning's been done. We have our designs and our models already approved, and we're going to move into a construction phase. So how can we use some of these technologies to make that process a lot more efficient? So I'll hand it back over to Nick here to talk about some of those options.
Thanks, Vince. So the use case here is, can we work safer in the field? Can we avoid utility strikes and have better situational awareness for underground utilities before we dig? In this example, I'm going to work from left to right, but we're basically going to use an iPad Pro to really display those augmented reality features, those features in augmented reality. So on the left-hand side, we have our typical design plan with survey control. Nothing changes there. It's how it's traditionally done. We can take that information, though, because it's been surveyed, and bring that into a GIS environment, primarily in ArcGIS Online or ArcGIS Portal, which is great because it allows us to pull from an authoritative data source. While we're in the field, we then simply point the iPad at the project site, and when paired with a GPS, a high-resolution GPS, it will display the utilities on the ground as you see them there on the right-hand side. And that provides situational awareness that is beyond what a traditional line locate can do. As you'll see on the left-hand side, there was the line locate right at that water valve, but it's painted only shortly right after the valve, where our GIS feature is displayed the entire length of the position. Also, just note that you can see the accuracy that we're right in line with that water valve cover, and we're also in alignment with the direction of the survey, the markout paint. Also on the right, you can see that there's a manhole with the same thing on the water side. Just be mindful that the one green line that's running kind of quasi-perpendicular is actually a garden hose. But otherwise, you can see that the utilities are in line there. Again, this technology is pairing mapping grade GPS with our augmented reality tools on an iPad and being able to project that information in the field for full situational awareness. So the idea is you can identify where the utilities are, where you have multiple utilities. In this case, on the right as well, you have a gas line. That orange line is a gas line that's right there as well. So you can see the full situation of the outline, how the utilities are laid out, and apply that before you start digging. Again, I'll note here saying that this is not meant to replace Survey Sioux. It's meant to supplement the work that they do. We need their accuracy and the work that they do to be able to locate these utilities. But again, they can't be in the field all the time. So this allows us to bring that information into the field and reasonably locate it with a mapping grade GPS receiver to have that situational awareness that we might not have otherwise. And I want to just bring attention to something that's very specific to the tools that we have here. If you notice in the center of that image, there's a slight change of direction There's probably an elbow that's maybe a 22-degree elbow there. And if you just use traditional line locates, they're going to mark out usually at the intersections of the valves and along there, but not the entire length. So standing from one valve to another, it may look like a straight line. But when you actually see and project the actual GIS data onto the ground, you do see that slight change in direction, which could be 6 to 8 inches difference in reality. And that's valuable information to when you're digging around there to know that there is that change of direction that might not otherwise get picked up either through traditional line locates or even just using a flat plan while you're out in the field. Okay, I'm going to switch gears slightly to the use case and describe another way we can capture field conditions for field visits or for repairs. Coming back to the tools that we already have in our pocket, all the iPad Pro tablets now include a LiDAR sensor, which can be used to capture scans. During a project dig, field staff can quickly capture the existing conditions through a scan, which can be viewed on site, in scale, or at a later time. How helpful would this be during an emergency repair at 3 o'clock in the morning, for instance, when the ground is covered with 6 inches of snow? Simply turn on the iPad and project the image of the excavated trench under normal conditions, and you'll see exactly the tools you need and where those cross connections are. You might need some special tools. You'll know that information before you start digging. So the augmented reality extends the GIS data by visualizing the information at scale and on site in 3D to provide real-world perspective that the GIS mapping simply cannot.
We saw a lot of examples here where we're actually out on site using AR/VR technologies to get better situational awareness. But what about users that might not be there on location? There's a lot of collaboration that happens back and forth between our field staff and engineers that really have all the information for that project design at their fingertips back in an office. So using some of the same scanning technologies, things like LiDAR and drones and photogrammetry, photo capture, we can take snapshots of that project during different phases, different parts of the project, and kind of get a view over time of exactly what that project looks like, how that project has been changing, and really get up-to-date information about the site itself. Using things like Apple Vision Pro, we can then take that 3D information, those meshes, and bring them into augmented reality experiences. So in here you can see we've got several different photogrammetry captures that have been taken over a period of time, and our user back on site can take those, view those things in 3D, really zoom into the details and kind of see a couple different levels of information. So not only can we do the photogrammetry and the reality capture that we have, but we can also show the alignment of the project plans themselves to kind of compare that to that as-built condition that you can see over time. So this gives us a really good immersive view for offline communication. So if we have to do something like a phone call back to talk to a user who's back at the office off-site, it helps that communication, makes those things really happen much quicker in real time so that issues on-site can be addressed faster, decisions can be made quicker, and we have a lot less project downtime. So we're moving into this phase where our project is built and delivered, right? So everything that we construct and build as a structure, whether it be a building, a bridge, any type of horizontal or vertical structure, has to be maintained and has to go into a phase of asset management. So again, we have a lot of ways that we can use AR/VR technologies and immersive technologies to build things like digital twins and have a lot more tools available to us to help make those asset management tasks a lot more efficient. I'll hand it back over to Nick here to show a couple different examples of exactly what we mean there.
Okay. Again, the use case here is that we want to document the work that's being done so we can use that information down the road for maintaining the asset. In this case, we were doing a manhole replacement in Pittsburgh. So we scanned that project site before the work was done, and then we walked back through and scanned it again. And you can see clearly that the manhole has been replaced with the precast concrete there. What's great about this is it does a couple things. First of all, it documents the project work is done. You have that before and after, so you can recall that for any needs for asset management. But also, it documents that we used the trench box, for instance, so we were working safely. And we can also use this for claims avoidance, where a contractor might say that something was done, and you can go back to that information and say, well, was it done, and was it done the way it was supposed to be done? And here we're using an iPad with the same workflow of using the LiDAR sensor on there. And we actually can export that 3D mesh out and bring this into our GIS Pro in this case, because we are, again, pairing it with that mapping grade GPS unit. So we can take that export out and work with it in other applications like an AutoCAD, Bentley, or MicroStation, or ArcGIS Pro. What's a great thing about this is it allows our crew to capture the information, but then also it's that trust but verify, that we have that information in there to be used for future needs as needed. Next slide, please. Okay. Along the same lines, we are here working at a lead service line replacement in Pittsburgh. And the use case is that we want to make sure we documented the work, but also can we use that information as part of our as-built validation process. So it's a very similar workflow as the ones we've said before, just the use case is slightly different. We're pairing that iPad Pro with that mapping grade GPS receiver. We're going to scan that trench. So here, there's the excavation of where that curb stop valve is. That's where the water main meets the service line that leads into the homeowner's home. And it's at that point where they're replacing that line work, that line for the lead service replacement. And I want you to take special note of that middle picture, because that's the actual 3D mesh that's captured from the scan by the iPad. There's a blue box in the middle there. That represents the curb stop itself. That's kind of the point of demarcation for the work being done. Now on the right-hand side is where we actually take that scan. So in this case, it's the scanning that's in the lower right-hand corner of that right box. And you can see that we've brought that into the design set, the design plan of drawings where all the proposed information was. Next slide, please. I'm going to zoom in a bit further on that area. And you can see the cyan light blue represented the proposed location for that valve, that curb stop valve, that blue box that I spoke of. You can see they do not line up perfectly. That blue box, it's a little bit hard to see there, but it's that blue kind of speck in the center of that scan. They're off by about 4.5, 5 feet. Since we captured that LiDAR scan with the map and grade GPS, we have some reasonable expected accuracies of about a couple inches horizontally in good atmospheric conditions. So we're well beyond the tolerance of that accuracy here. We can clearly see that the line is off. So you can do a couple things with this. You can update your drawing as needed, or you could also trigger to send out a survey crew to go back out there and say, hey, we missed something. Something's off here. Let's make sure that our design plans, when we want to generate as-builts from these, that they reflect the real world conditions. And this is just a great workflow to show how field staff who are going to go there and capture pictures anyway, but if they capture them in a certain way, in this case using the LiDAR sensor rather than just a regular digital camera on the iPad, how you can extend the value of those outputs significantly to operationalize and work with that data in a significantly different manner than just a digital picture. Slide, please. I'm going to switch gears a little bit, where our use case now is looking at validating the work that's been built. Here we have a 3D model of water piping compared to the mesh captured of the reality. So you're looking at the design versus the build. In this case, you can see where the design and the build don't align perfectly. In some cases, they're off by a foot or two. And can we use the tools that we have to identify those discrepancies before the work is completed? By overlaying the 3D mesh with the models, that allows us to identify those discrepancies earlier on in the project and maybe stop something before it becomes a large problem. Can we redesign something before the work is finished, or stop the work before we have to have a huge change order that can add project delays and cost? So this is a really good example, a great visual of how the tools can really help that use case. The idea is that you have that model projected and you're looking at the meshes and comparing as the project goes along, not just at the end of the project. So that will be where you can kind of really start to see those discrepancies happening and try to get ahead of that before it becomes a real problem. Next slide I'm going to show you is going to take that same workflow indoors. So here we're using a technology called VPS, which stands for Visual Position Systems. A lot of times our construction management staff deal with work that on a flat 2D plans when the building is 3D. It's common for our project teams to have iPads on site to view the plans in 3D models. However, they're still viewing, if they're using an iPad, they're viewing that on a flat surface. As I mentioned in the previous slide, this can be challenging to validate build matches versus designs. But let's go to AR again to look and see how we can do some support. In this case, at an airport, we're building a new baggage carousel that's going to be constructed. But what if we could see that model in that space at scale before we built it? Where we can't use traditional GNSS. We're inside, so GPS is not going to be a reliable localization methodology. So again, we're exploring newer technology called visual position systems to support this use case. Basically, in short, VPS uses the tablet's camera and computer vision algorithms to localize and orient to place that model in space. Through VPS, our construction management teams can natively see the design and build on the build on site and at a scale to identify where the misalignment could be occurring. These tools allow them to rectify an issue much earlier in the process than with traditional methods. You can also extend this use case out at the design level too. While you're going through your 30, 60, or 90% design, you can bring that model into space and have the designers walk it and seeing how it lays out. Does it make sense? Is it going to fit? Is there something that we missed in our design plans of current conditions that now we're seeing as part of the real world scenario that we have to design around? So there's two use cases here where the models can really, once they're projected into that space at scale, they can add a lot of value during design and also during construction. I'm going to hand it over back to Vince to show how models can be also used using some of his other tools as well.
Thanks, Nick. We teased out this idea of a digital twin a couple of different times, and I wanted to show some examples of exactly what that kind of looks like. So again, we've got a 3D model. We've got some additional resources here where we've got 3D geospatial information. We have some reality capture meshes that we're taking with, survey grade reality capture techniques, some drone techniques and things like that. And we overlaid those all together to kind of give a really good immersive view of this particular bridge project. So you can see here, we've got the bridge. You can turn on a lot of different layers on and off and really explore that entire area. But it also opens up the ability for us to connect with third-party data like IoT systems. So in this case, we've got some 511 data that we were able to pull from our 511 cameras to see traffic information in real time. So around the surrounding area, around the bridge, we can pull up all the different traffic feeds, and you can see you can click on any particular one of those. The actual model will reorient, so it gives you the same perspective and the same context of what that camera is looking at, and it pairs it next to a video feed of real-time traffic information. We can pull up things like digital messaging signs and all types of connected devices that happen throughout that roadway. That could be extended to bridge inspections as well. If we have bridge sensors and different roadway sensors and things like that we tie in, we can bring those all together in one cohesive view alongside with the model so that we can get a much broader picture of exactly what's happening in real time without actually having anybody be there, particularly on site. So as things change and there are emergency situations, those things can be addressed and handled much quicker. So we showed a lot of these different technologies and things that we are working with to, again, enhance our workflows, enhance communication, really leverage the idea of a 3D model as being part of our entire workflow. We wanted to share a couple of the things of the lessons learned. One of the things is always start with our use case. A lot of the things that Nick and I talked about here are really a combination of either off-the-shelf products, configurable products, things that we can leverage, using tools like Bentley, Autodesk, Esri, Trimble. But really, the end product is what we really want to focus on. We want to think about the use case, how it can add value to our projects, to our processes, and build from there, because we can assemble and connect these things in a lot of different ways. But we want to make sure that it's usable and really adds value at the end when we try to apply that to a project. The other thing is capture everything and often. As Nick mentioned several different times, we have users that are out there, field staff that are out working every day. They've got these iPads and phones and mobile devices that offer us a lot of capabilities to do scanning on a regular basis. We have our reality capture and survey teams who can go out with much higher grade and higher detailed information. We have drone technology that we can utilize throughout the entire project to capture, snapshots over time. So the more of that 3D information, the more of that reality capture information that we have available to us, the more detailed and the more enhanced we can make these immersive products, because we have all those things to work with. One of the first things that we always talk about when we engage with any of our clients is, what reality capture data do you have, and do you have an accurate geo-referenced 3D model that we can work from? Because that solves a lot of the challenges in us being able to utilize a lot of these technologies to add value. And finally, 3D modeling is key. We talked a lot about digital delivery and that kind of evolution within the AEC space of utilizing a 3D model as a deliverable, as something that is, legally binding and becomes kind of really part of our workflow. So it really is helpful and beneficial throughout the entire project to really embrace that idea and think about digital delivery as a new way of working as we continue forward, because we can see there's a lot of benefits that can be gleaned from it. So please connect with us. We can see our QR codes there to connect with Nick and I, or reach out if you have any ideas. If you want to see some of these things in a little bit greater depth, more than happy to, of course, talk with folks and kind of really dig into some of the details on some of these things.